Alrighty, thanks for checking in. This video here will go over the Unit 1 test topics for Math 2. Alright, first topic in the list is identify a polygon by their precise name. Such as, if you see a picture that looks like that, you would call it a scalene triangle. Not just a triangle, but a scalene triangle. Or if you saw that, hopefully you would know to call that a rhombus. Or what about this guy here? I see a pair of parallel lines. I see two other sides that are congruent. That must mean it's an isosceles trapezoid. Okay, so some problems like that. Here's the next item in the list. Using a Venn diagram to sort polygons by their attributes. This is just a screenshot of one of those problems we did early in the chapter from the Desmos graphing calculator program. Sorting those shapes, I'll have something much simpler in terms of how many shapes, just much fewer shapes, but you should be able to decide whether a polygon has parallel sides or congruent sides or a line of symmetry of some kind, and sort those polygons according to those attributes. Next thing in the list is to simply multiply two binomials together, something like that. And if you're unsure about that, check out the video that I already have posted in there about multiplying binomials. If you think that's easy, cool, that'll be a slam dunk problem. Next item in the list is basically just to solve some simple linear equations. Here's a hard one to look at, one with a fraction in it where you have to cross multiply and blah, 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 you get your solution. Sometimes it's a kind of an inconvenient looking fraction like 3/17. But solving an equation will be part of many problems on the test, and including things like this, write and solve equations based on different kinds of special angle pair relationships, such as if you have a diagram like that, hopefully you recognize that as being supplementary angles so that the two angles add up to 180 degrees, which is a pretty easy equation to solve. All right, and there you go, there's your answer. Here's another example of something like that. A couple of parallel lines crossed by a transversal. Hopefully you can read that in there, 9x minus 4 and 50 degrees. Those are alternate interior angles, which hopefully you remember are equal. And so that it forms the basis of your equation. 9x minus 4 equals 50. And you solve that, and you get your answer. All right, so special angle pair relationships, you'll write some equations based on those. You'll also write some equations based on the properties of polygons, such as you see that shape right there. It's a rectangle, and if you see that one side is 15 and the other side is 8x minus 17, hopefully you recognize that those two sides must be equal. There's your equation, 8x minus 17 equals 15, and you can solve that equation. Or maybe something like this. Our old friend, the isosceles triangle. Two congruent sides means their measurements are equal, and that's your equation. 2x minus 11 equals x plus 23. That's not so hard to solve, right? You've done stuff like that already, and you can come up with your answer for that kind of a problem. All right? Last and not least, is a question or two on the triangle inequality principle, which is the last thing that we've learned in this chapter, so you don't get a whole lot of time to practice this. But let's say you have two sides given like this, one side's 7, one side's 12. What is the range of possible lengths for the third side, which I've labeled x? And remember, we don't know anything about the angle in between those two sides. So it might look like that, or it might look quite a bit different. But you've got a 7 and a 12, and you're trying to figure out how long that third side could be. Well, if you remember, actually from just today, that you can figure this out by doing two very easy calculations, 12 minus 7 and 12 plus 7. 12 minus 7 is 5, of course, and 12 plus 7 is 19. So that gives you the lowest and the highest possible measurements for that third side. And you would use inequality symbols like this. So just put the smallest number on the left, the biggest number on the right, make two less than signs with the x in the middle, and you've got your solution expressed perfectly right there. You might also see a question like this, where if you have a triangle with two angles given, perhaps I might ask you to list the sides of this triangle in order from shortest to longest. And if you remember, the shortest side is always opposite the smallest angle, and the longest side is always opposite the biggest angle. That's part of the triangle inequality principle. So you can see that we only know two angles here, so we have to figure out what is that third angle before we can really finish off this problem. So hopefully you remember that the three angles inside a triangle, the three interior angles, add up to 180 degrees, so you can quickly figure out that third angle there is 72 degrees. Okay, 72 degrees. So now I can list the sides of the triangle from shortest to longest. I see 40 degrees is the smallest angle. Opposite that is side C, so that's my first side. 68 degrees is the next biggest angle, and the side opposite 68 degrees is side B. And finally, side A is opposite the largest angle, and there's my list of the three sides. Okay, well, I hope that was useful for you. Let me know what questions you have. Just write them in the forum, and I will try to answer them. And of course, if someone else asks a question in the forum, you can answer that question. Alrighty, thanks very much for watching.